Okay, so here in this video we're going to determine the antiderivatives of our trig functions. And before we start taking antiderivatives of trig functions, let's recall the derivatives of our trig functions. The derivative of sine u is cosine u times u prime. The derivative of cosine u is negative sine u times u prime, because the derivative of a c function is a negative answer. The derivative of tangent u is secant squared u times u prime. The derivative of cotangent u is negative cosecant squared u times u prime. The derivative of cosecant u is negative cosecant u cotangent u times u prime. And the derivative of secant u is secant u tangent u times u prime. So in this column we have all the derivatives. Now in going backwards, we're going to be given this derivative and we have to come up with the function whose derivative is given to us. So in the reverse process, this would imply that we would be given the indefinite integral of cosine u du would be equal to sine u plus c, because the derivative of sine u is cosine u times u prime. And the derivative, of course, the constant is just 0. This would imply that the antiderivative of sine u du, now because we are not given the negative here in the integrand, our answer will contain the negative. So a function whose derivative is positive sine u is negative cosine u plus c. As you check, when you take the derivative of cosine right here, the derivative of a c function is a negative answer. So the derivative of cosine is negative sine, but times this negative would now yield a positive sine. And the derivative of c again is just 0. The bottom line is that when you end up with an answer that is a c function, it is negative. Next, this would imply that the indefinite integral of secant squared u du is equal to tangent u plus c, because the derivative of tangent is secant squared. This would imply that the indefinite integral of cosecant squared u du would be equal to negative cotangent u plus c, because our answer is a c function, so it is negative. And as a double check, the derivative of cotangent is negative cosecant squared u, times this negative would now yield a positive cosecant squared u. Next, this would imply that the indefinite integral of cosecant u cotangent u du would be equal to negative cosecant u plus c. The derivative of cosecant u is negative cosecant u cotangent u, times that negative would now yield a positive cosecant u cotangent u. And the indefinite integral of secant u tangent u du would be equal to secant u plus c, because the derivative of secant u is secant u tangent u. So if you look here in the integrand, in each of these is a derivative that we know. So we have to come up with a function whose derivative is given to us in the integrand. And the bottom line is that when you end up with the answer being a c function, then the answer is negative. If the answer is a c trigonometric function, the answer is negative. Because of the fact when we take the derivative of a c function, the answer is negative. Okay? So can we generate the table of antiderivatives, or the list of antiderivatives, without writing out all the functions and their derivatives? So here's what we have in summary. The indefinite integral of sine u du is equal to negative cosine u plus c. Because of the fact the derivative of cosine is negative sine times a negative is a positive. Another derivative we know of is cosine u du. So then therefore its antiderivative would be sine u plus c. And the derivative of sine is just cosine as a check. What's another derivative we know? Secant squared u du. What is that the derivative of? It's the derivative of tangent u plus c. The indefinite integral of cosecant squared u du. What function has a derivative of positive cosecant squared u du? Well, that would be not cotangent, but negative cotangent u plus c. Because the derivative of cotangent is negative cosecant squared, a negative times a negative would now be a positive. The indefinite integral of cosecant u cotangent u du. What function has a derivative cosecant u cotangent u? And that is cosecant u plus c. But because the answer is a c function, it gets a negative. And finally, the last derivative we are missing would be secant u tangent u du. And that would be equal to secant u plus c. So now when we deal with the trigonometric functions, we have to mold the integrand into looking into one of these 6 forms. Sine u, cosine u, secant squared u, cosecant squared u, cosecant u cotangent u, and secant u tangent u. So this is the 6 forms for the trigonometric functions that we are working with right now, that we have to mold the integrand into one of these 6. And if we add the one that we already know, that the indefinite integral of u to the nth power du is equal to u to the n plus 1 over n plus 1 plus c, where we mold the integrand into u to the nth power. Its antiderivative is u to the n plus 1 over n plus 1, provided, of course, n, the power, is never equal to negative 1, because adding 1 to that would be 0, and we cannot divide by 0. So far, this is a summary of all the antiderivatives we have, and this is the hit list. All of our integrands, when we're doing a u substitution, have to be molded into one of these 7 forms. Sine u, cosine u, secant squared u, cosecant squared u, cosecant cotangent, secant tangent, and of course the one where we started with u to the nth power. So that's a summary of all the antiderivatives we have so far. In the next video, we'll look at more examples of taking the antiderivatives of these functions.